If you've worked on a software project, you know, right? You get the deadline, you make this beautiful plan, and then, inevitably, it's late. It happens all the time. So why? What's going on? Today, we're going to dig into what's really derailing our projects. Let's get into it.
Fred Brooks, the author, kicks things off with this gem. And it hits the nail on the head, doesn't it? The whole point here is to learn from the giants who came before us, the folks who built these massive, complex systems, so that we don't have to be the ones learning every single painful lesson from scratch.
This is the big question, the mystery we're trying to solve. For decades, this has driven developers and managers absolutely crazy. It feels like every estimate is just a wild guess. But what if we've been looking at it all wrong? What if the problem isn't our ability to guess, but the way we're measuring the work in the first place?
All right, let's dive into our first big clue. And this one points to a massive mistake we all make when we think about how big a project is versus how much work it'll take. Turns out what feels right in our gut is, well, it's completely dangerously wrong.
So the book has a term for this, linear extrapolation, and it's a trap we all fall into. Think about it like this. You time a sprinter running 100 yards. You can't just multiply that time by, 400 and some to figure out their marathon time, right? That's ridiculous. You're ignoring everything, fatigue, pacing, the sheer complexity of a long race. Well, it's the exact same thing with software. A huge system isn't just a tiny program scaled up. It is a totally different animal.
So on the one hand, you've got our intuition. Makes sense, right? A project that's twice as big should take, twice the work. Seems logical. But then there's reality. And the reality, which is backed up by actual studies, is that the effort doesn't just grow, it explodes. It goes exponential.
And get this, they actually put a number on it. Effort scales to the power of 1.5 of the program's size. So let that sink in. A program that's 10 times bigger doesn't take 10 times the effort. No. It takes over 30 times the effort. That's insane. And this one little number tells us something huge. Size all by itself creates its own crushing complexity.
Okay, so if the effort is blowing up exponentially, why? What's actually causing that massive jump? Well, for that, we need to look at the evidence. Let's open up some case files from the field and see what researchers found when they went looking for the culprits.
First up, we have case file number 1, the Portman study. So there's this manager, Charles Portman, and he's got a problem. His teams are sharp. Their estimates are careful, but they are always late, like by half. Every project is taking twice as long as it should. So he decides to find out why, and he makes them track everything.
And what he found was a huge eye-opener. The big, flawed assumption in every estimate was that a 40-hour work week actually meant 40 hours of coding and debugging. But the reality? Nope. Only about half that time, just 50%, was spent on the actual technical work. The other half? Gone. Eaten up by meetings, paperwork, system downtime, you name it. So there's culprit number 1. We're planning for a perfect, focused week that just doesn't exist. All right, on to case file number 2. This one from a guy named Joel Aaron over at IBM. And Aaron's angle was a little different. He wasn't just looking at the clock, he was looking at the people. Specifically, how much they had to talk to each other to get anything done.
And wow, the results here are just staggering. When developers could basically work on their own, productivity was fantastic. But the second you started needing more teamwork, more interaction, productivity just fell off a cliff. It dropped by half. And then, with many interactions, it dropped by another 70%. And there's our second culprit, communication overhead. It's a tax. Every single person you add to the team adds a whole new web of conversations, meetings, and emails that just slows the whole thing down.
Okay, our last case file brings in evidence from a couple of heavy hitters, John Haar at Bell Labs, and data from IBM's Monster OS/360 project. And this clue isn't about how we spend our time or how we talk to each other. Nope, this one is about the work itself. And the data shows this huge difference. Teams building something like a language translator were cranking out work almost 4 times faster than teams building really deep, complex control programs, think operating systems. And that gives us culprit number 3, inherent complexity. Some jobs are just plain harder than others. You can't measure building a skyscraper with the same ruler you use for a garden shed.
So I know, this is all starting to sound a little bleak, right? Effort explodes, our work week is a lie, talking to people slows us down, and the work is ridiculously hard. But hang on, because this is where the story takes a turn. Our investigation found a breakthrough, a clue that points to a really powerful weapon we can use.
In this final, crucial piece of the puzzle comes from MIT, from the team that built the Multics system. And these guys had a secret weapon. They were using a brand new, much more powerful tool to build their software, a high-level programming language.
So researchers crunched the numbers on their productivity, and it came out to about 1,200 lines of code per person per year. And, looking at our other case files, that number seems fine, I guess. It's better than the operating system folks, but not as good as the translator teams. Kind of middle of the road. So what's the big deal? Aha! But that's the thing. There is a catch. That number, 1,200, is hiding the most important part of the story. Because the way they were measuring has changed. And that changes everything. See, here's the key. All those other studies, they were measuring productivity in machine instructions, like the absolute rock-bottom ones and zeros level of code. But Corbatado's team at MIT, they were writing in a high-level language. And in that language, just one of their statements did the work of 3, 4, even 5 of those old-school machine instructions. Every single line of code was more powerful.
And that is the punchline. When you factor in how much more powerful their tool was, their real productivity was actually up to 5 times higher. This is huge. It shows that using the right high-level language isn't just a small improvement. It is a massive force multiplier. It gives a team the power to tackle complexity that would just crush them otherwise.
So what does all this mean for us right now? I mean, this stuff is from decades ago, and we're building things with AI and the cloud. Well, let's wrap this all up and distill these clues into a modern-day playbook.
Okay, here's the guide, the cheat sheet from all this. Number 1, effort blows up with size. It's exponential, not linear. Got it? Number 2, plan for a real week with all its interruptions, not some fantasy coding marathon. Number 3, always factor in the communication tax that comes with a bigger team. 4, respect the beast. Some problems are just a lot harder than others. And finally, the most important one, use the right tools for the job. They're not just tools, they are productivity multipliers. The crazy thing is, these lessons are just as true today as they were back in the 60s. The tech is different, sure, but the human challenges, the system challenges, they're exactly the same. So I'll leave you with this question. Now that you know about these hidden forces, the next time someone asks you, so how long is this going to take? What are you going to do differently?